So for chapter 12, we're going to talk about solutions. Solutions are important in our lives because we mix solutions for cleaning in our house. We mix solutions when we use fertilizers, chemicals in our gardens, in our fields. And so it's important for us to understand what a solution is and how to mix solutions safely and properly. So there's two kinds of solutions, or two kinds of mixtures, I should say. Homogeneous mixtures and heterogeneous mixtures. The homogeneous mixtures are going to be also known as solutions. So we usually use this word solution almost too broadly. Solutions have to be where the substances are uniformly dispersed throughout the phase. So if we look at this example down here, we have a solute dissolving in a solvent. Now the definitions of solute is the substance being dissolved, and solvent is the dissolving medium. So if we put our solute in our solvent, it will disperse evenly throughout. So if you look at this, it would be evenly distributed. That is the definition of a homogeneous mixture and a solution. When we move on to the different types of solution, you can have gases dissolved in gases, you can have gas dissolved in liquids, liquids in liquids, liquids in solids, solids in liquids, and solids in solids. And these are the examples of these types of solutions. So sometimes we just tend to think of solutions as salt in water or sugar in water or making Kool-Aid. But solutions are so many more of the phases mixed in other phases. So just remember that, and you can look at those examples. Heterogeneous mixtures, then, are those that are not uniformly mixed. If they're not uniformly mixed, they will form like layers that you see here, or layers that you'll see there, or it will be a dispersed, I gotta find the next page, sorry. So, or it'll be like a colloid where the particles will stay in suspension for a longer period of time, but they're not evenly dispersed and in time will settle out. So how to determine whether something is a suspension or a colloid is one of our things that we need to try to figure out. So when we talk about the colloid is going to have, instead of calling them solvents and solutes, they're going to have a dispersing phase and a dispersing medium. The dispersing phase would be equivalent to the solute in a solution, and the dispersing medium would be equivalent to the solvent. But because they don't evenly distribute, we have to use this terminology for colloids and suspensions. So just remember, dispersed means that is what's going to be dispersed within the medium, the dispersing medium. So for the types of colloids here, if you look, sometimes we don't think of this as being a solution or a colloid, but that is pretty uniformly dispersed particles, but they can be separated. They would settle out. Some of those items would settle out. Jello would be considered a colloid. Now you may think, oh, it's evenly distributed and it's all, even and the same throughout, but it's not. It is going to have a property that doesn't let light pass through it, and we're going to get to that in a minute. But types of colloids here. Here is a chart that gives you all the different types of colloids so that we can get these things that we have in our head that we have around us every day and help us identify them as colloids versus solutions. So here are the examples that go with the different types of colloids or suspensions. So solids can be dissolved in solids, and that would be some of your alloys, because we can mix them in different amounts and different ways. Cranberry glass, probably not something that we see every day, but there is a solid mineral dissolved in the glass to make it a reddish color. Solid dissolved in liquids, that would be ink and blood. Blood has the liquid plasma, and it's going to then have solid, this is the liquid, then it has solid red blood cells, white blood cells, and platelets. So blood can be separated by the solid particles and the plasma. And I know people will donate plasma and they will keep all their cells. So they will pull your blood out, just get the plasma, and then send your blood back in. Send the red blood cells, white blood cells, and your platelets back into your body. So they do that. Liquids in solids, making your jellies and curds. Smoke is a solid. Smoke will settle out, form on your walls. So, smoke is, can make things dirty. Like volcanic ash in the air is one of those examples. So those are all your types of dispersed mediums and dispersed phases. Now, all gases are miscible. So we're going to have to talk about the miscibility terminology later. So we'll get to that. Colloids then, this is just another picture of the different colloids. Milk is a colloid. If you have fresh milk, it will settle out and become, it'll settle out and have cream at the top. So how do we determine? Now I'm sorry, my notes got a little off when I transfer them from one form to another. But the Tyndall effect here. The Tyndall effect is when light is scattered by a colloidal particles dispersed in a transparent medium. So this kind of goes across here. But the Tyndall effect, if you look at this example down here, the Tyndall effect is right here, passing this light through. If it is a solution, the light will go straight through. And it works great with a laser beam, and you can see on the other side, the laser beam will come through. If I put a sheet of paper right here, you'll see the laser beam dot there. But if you do the same thing with the laser beam through a colloid, these particles are going to scatter the light, and it will not shine on the other side. So if the light beam is, pure water, you can see it goes through. Colloidal, you're going to see the light beam because it's going to be dispersed in there. But if you do a laser beam, you'll see that laser light come all the way through. And that's called the Tyndall effect. That is also what happens when you're driving your car and there's a snowstorm and your headlights are going to reflect off the snowflakes, and you are going to see that light being scattered, and that shines some of that light back into your eyes, and that's why you put your beams on low beam when you're driving. So when you're driving in a snowstorm, you're going to go, oh, that Tyndall effect is really bothering my driving today. So Brownian motion is the random movement of molecules. So the example right down here, you can see smoke particles. This is an example of Brownian motion. Smoke particles that are just going to move, like if this is my smoke particle, it's going to go this way. If it bounces off something, it'll go this way. Bounce off something, it'll go this way. So random motion. So the snowflakes in the air have random motion. So you can check out this chart here. It's going to talk about the particle size and properties of each of the three types of mixtures that we're talking about: solutions, colloids, and suspensions. And I would take a look at that, and that is going to be a summary of those notes that we just had. So for our next term, how it applies to us, and something that you're probably exposed to every day, is when you hear the word electrolyte. Electrolytes are substances that dissolve in water to give a solution, that help a solution conduct an electric current. Sorry about the wording there. But electrolytes, if they're dissolved in a solution, will help the solution conduct an electric current. If you look at these three examples, ethanol is a covalent molecule, and so therefore they do not separate into ions, whereas these two will separate into ions, this one more so than this one. Your electrolytes that you have in your body are right here. sodium, potassium, chloride, calcium, magnesium, as well as others, but these are some of the major ones. These are the ones that Gatorade and Powerade companies are always pushing you to drink their product in order to get. But you can get these through eating food. Most of us get all of these items and enough of them by eating food. Now, people who are running like a marathon and are going to sweat out these electrolytes in a massive way for a long period of time will need to put those in a way that is not with food because they are not able to stop and eat a meal while they're running their marathon. So we need to keep that in mind. But electrolytes are formed from ionic compounds. They are ions put together. And this is just some charts that tell you where you would get some of those different electrolytes. You do not have to get them from a sugar drink. You can get them from these other places, which would be healthier. A non-electrolyte then would be a substance that dissolves in water to give a solution that does not conduct an electric current. So these would be from molecules, which are covalent bonds, which will not separate. And remember, that's where they share the electrons, the covalent bonds. And so when they're in solution, they don't need to separate, they stay together. And so non-electrolytes are not going to dissolve in water to make an electric current in the solution. So that is section 1 for chapter 12. Our next video will be for section 2. Have a great day.